Testing, testing. Okay, so I did get some questions for our class review. You might want to thank Sean, since he's really the only one who sent in any significant number of questions. Also, Jenna, the one question you sent in is not relevant to the exam, so don't worry about it. All right, that was number 8, D and E. If you were okay with the rest of number 8, then you're fine. All right, so I have, I think, 7 questions that I'm going to go over. And the first one is on the screen here. It is on page 57, number 5. And you can read it. You don't need me to read it to you. All right, so the basic idea here and the parts of the question that we're interested in are, let me see, what do I have here? A, B, C, and D. Don't worry about E or F for this question. All right, so we're starting off with 2 data points for 2 different pieces of information. In 1990, there are 442.2 million pre-recorded cassette tapes and 856.7 million CDs. All right, so we start off with, just as usual, where is my, hey, come back here. Damn it, cancel. Okay, sorry about that. Okay, so we're starting off just like usual with t equals 0, corresponding to 1990. All right, and then we're going to have 2 different data points here, okay? So we'll do, what comes first? Cassette tapes. Cassette. And the cassette tapes are 442.2. There we go. And CDs, which are 865.7. All right, and then in 1998, so that is going to be 8 years later, right? T equals 8 is going to be 1998. And in 1998, there are 158.5 million cassette tapes and 1,124.3 million CDs. All right. Now, he says to assume, incorrectly, that the pattern of the sales of both items is linear. All right, so for parts A and B, we want to find a function, an equation, for the number of cassette tapes and for the number of CDs. These are 2 separate equations. All right, so what we have are basically 2 points for each one. So if I do, let's do cassettes over here. So I'm going to use F is going to be for the number of cassettes. And the points that I have to work with for the number of cassettes are 0. Let me see, cassettes are up there. There we go. 442.2 and 8, 158.5. All right, so what this comes down to is write the equation of a line through those 2 points. So we need the slope and the y-intercept. We have the y-intercept right here. All right, so that makes things easier. All I need to do is find the slope here. All right, so m is going to be, all right, the difference in the y's, 158.5 minus 442.2 over the difference in the x's, which is going to be 8 minus 0. And if you drop this into your calculator, you will get negative 35.46. Negative 35 0.46. All right, which makes f of x, we'll let x be, oh, I was using t. All right, never mind, that's a t. Sorry, this isn't like the chalkboard. I can't just erase it easily. All right, f of t is going to be, right, what is it? It's m times t plus b. So the slope minus 35.46 times t plus the y-intercept, which is what happens when t is 0. So that's 442.2. So there's our first equation. You're going to go through the exact same set of steps to get the equation for the CDs. All right, so we'll let G be the number of CDs. All right, if you calculate the slope for that one comes out to be, where is it? 32.33. All right, you're going to use these two values this time. All right, so G of t ends up being 32.33 times t plus, now the y-intercept for this one is, again, when t is 0, right, we're at 865.7. So 865.7. All right, so now we have our two equations. All right, and that takes care of parts A and B. Now for C, what is the practical significance of the slopes in those two? Basically, all he wants you to do there is to interpret what the slope means. All right, so for each one of them, so for F, right, F is representing the number of cassettes. All right, so each year, the number of cassettes will decrease by 35.46. All right, decrease because the slope is negative. For G, all right, every year, the number of CDs will increase by 32.33. Again, increase because the slope is positive. So that's all you need to do to answer part C. And then part D is kind of an interesting one. Basically, what he's asking you there is when, let's see, if the trend in the sales are indeed linear, find when the number of CDs sold overtook the number of cassette tapes sold. All right, so there's two ways to do this. One is to graph each of those equations on your calculator and find the point where the two lines intersect. All right, that I'll leave that to you, just because I don't have my calculator set up right now. But you could do it algebraically. All right, that's what I'm going to do here. All right, so to solve this algebraically, what you would need to do is take the two equations. All right, wait, let me do it here. Minus 35.46t plus 442.2 equal to 32.33t plus 867. No, 865. It's always worse when I don't have you guys sitting there yelling at me when I do something wrong. All right, anyway. All right, so that's what we got. You're looking for the place where the two are equal. All right, and that's how you would set it up algebraically. So if you solve this equation, just bring all your t's to one side and all your constants to the other side. So if I subtract the 865.7 over to this side, all right, so I'm going to take this and I'm going to move it over there. Got to subtract that over. That means I want to move my t's this way, so I'm going to move this t over here. I'm going to have to add that over. So what I'm going to end up with, if I do that on the left, is negative 423.5. And on the right, 67.79 t. All right. Divide both sides by 67.79, and you will get t equals negative 6.2. Now, I know I keep saying time can't be negative, but remember, time equals 0 is 1990. So t being negative just means we are before 1990. So if I take 1990 and subtract 6.2, I am going to get 1983.8. Okay. And all that means is sometime during 1983 is when CDs overtook cassettes, according to these equations, according to this data. Whether that's actually true or not, I don't know. Okay. All right, now as far as the other two parts go, don't worry about parts E and F for that one. That is not anything I'm going to test you on. All right. Okay, so the next question. Oh, and then there was another question on that page that Sean asks. Basically, it's the same question, but with different contexts. It's the DJ problem. So you can follow this one to do that problem. All right, so the next one is on page 85, which for me is 105. All right, so it's on page 85. All right, skip number 12. You asked me about number 12, so I'm going to just skip number 12. Don't worry about it. I think this is number 23. Let me see. Which is right over there. Okay. Why do I feel like... Oh, no, this is it. Okay. Lost track there. Okay. So number 23 doesn't have any context behind it. All right. But it's asking you a question about which of... Given the initial information there, an exponential function such that f of 0 is 512 and f of 4 is 1250, which of the values are possible? Now, there are two ways to do this. One of the ways to do this, get a blank page here. Okay. One of the ways to do this is going to be, wait, did I do that right? Yeah, okay. Sorry. One of the ways to do this is going to be to actually construct the function. That's the more difficult way. All right. A better way to do it is to understand what it's asking. So basically what they're giving you are, think of this like a table of values. All right. You got an X and a Y. All right. So let's set that up. X and Y. All right. So they're saying when X is 0, Y is 512. All right, now, the next value they give you is 4, but the value they're asking you about is 2. So I'm going to throw the 2 in there. Let's throw the 2 in there for a minute. And then when X is 4, Y is 1250. All right, now remember, this is an exponential function, which means as long as you have a uniformly distributed X, 0, 2, 4, counts as uniformly distributed. Then I should be able to take the ratio of successive y's, and if the function is indeed exponential, those ratios will be the same. So test each of the values he gives you. All right, if we let y be 800, all right, so if we let y be 800, then what I want to test is here and here. Now I'm going to come down here to write it. All right, so that becomes, let me just make sure I got my numbers right here. 800 over 512. All right, so 800 over 512 and 1250 over 800. Now, if 800 is the correct value, these should be the same. All right, so if I divide this out, I get 1.5625. 1.5625. And if I divide this out, I get 1.5625. All right, which means 800 is the correct value to go in between there. If you test the other two in exactly the same way, you will see you get different values. 881, let me see, I have it written here. 881 gives you 1.72 and 1.41, so those are not the same. And 981 gives you 1.91 and 1.27, so those are not the same. All right, so 800 is the correct value to put in there. All right, but again, thinking about what it means to be an exponential function when you have data from a table like this. All right, so that one was pretty straightforward, as long as you understood what he was asking you to do there. All right, so let's move on to 26, which is the next one that I got asked on this page. All right, so when Steve was 5 years old, his grandmother decided to set up an account to pay for his college. At Steve's 18th birthday, that's not the end, she wants to have $80,000 in the account to pay for college. The account pays 6% per year, and so we want to figure out how much did she start with. So this is an exponential growth function, okay? And what we're looking for is the initial value. So let me get a clean page here. All right. So remember, our general form for exponential growth is P of t equals P0 c to the t. P0 is what we're going to be looking for here. All right, so let's pick the information out of the problem. So first of all, we need to come up with C. So they tell us that the account pays 6% per year, so that's the R. Where am I? All right, so R is 6%, or 0.06. So I need to calculate C, which is 1 plus R. All right, so that's 1 plus 0.06, which is 1.06. Okay, so now P of t is going to be P0 times 1.06 to the t, and that is my equation. Now I want to find P, but I have information. I know from the problem that when t is 18, P has to be 80,000. All right, so on this side, I put the 80,000. P0 is what I'm looking for. 1.06 to the 18. Okay, so now, if I put 1.06 to the 18 in my calculator, all right, so we still got the 80,000 here, I get 2.8543. So 2.8543. Now just solve for P. Divide both sides by 2.8543. And 80,000 divided by that ends up being 28,027. 28,027.89, And I am rounding this to 2 decimal places because this is money, right? All right. So the initial amount that she'll have to put in her account in dollars and cents is $28,027.89. All right. Okay. All right, what do I have next here? All right, so the next question I have is on page 96, which is 106, 116 for me. And it is number 8. Okay. All right, so in 1940, there were 6,102 farms in the United States. In 1997, the number of farms had dropped to 1,912,000. 1,912? No, 1,912,000, sorry. Okay, so assuming that the pattern of decay is exponential, find the equation. All right, so again, we're looking for an exponential growth / decay equation here. So again, let me get a blank page. All right, so let's pull out now. I don't want to work in millions, so I'm gonna transfer this over to decimal values that we'll call millions. You'll see when I do it. All right, so we're starting this in 1940. All right, so in 1940, it's going to correspond to t equals 0. All right, and there are 6,102,000. So that is going to translate for me into p equals 6.102 million. Just because I don't want to work with those huge numbers. All right, then in 1997, that is going to correspond to t equals, sorry, my phone just alerted. That is going to correspond to, where did I put it? T equals 57. All right, and P is, what is P? 1.912. 1.912 million. Okay, I think that's all I need that for. All right, so I've got 2 points, and I have the general form here for my exponential growth / decay function. Now, p equals 0. Well, I know t is 0 in 1940, or at least that's what I'm calling t is 0, which makes 6.102 p0. And then I know 57 years later, p is 1.912. So I can plug all that in. So 1.912 equals p0, 6.102. Now, I don't know what C is. That's what I'm going to have to look for. And then T is 57 at this point. All right, so plug everything in, and then we got to solve for C. So divide both sides by 6.102. All right, if I do that, I get 0.3133. 0.3133. Now remember how to solve this. C to the 57 equals this number over here, so that means C equals 0.3133 to the 1 over 57. Put that in your calculator carefully, and you should get out 0.9798. So 0.9798. All right. All right, now we can put the whole equation together. So P of t equals P0, 6.102, times C, 0.9798 to the t. All right, now once you have that equation, you can answer the rest. That was all the work. The rest of this is just dropping stuff into your calculator or doing a basic solve. So for B, use your model. Just worry about the first part. Use your model to predict the number of farms in 1980. All right, so for part B, if t equals 0 is 1940, then 1980 is going to be t equals 40. Plug that in for t right there, drop it into your calculator, spit out an answer. For C, predict the number in 2005. All right, well again, 2005, if t equals 0 is 1940, then 2005 is t equals 65. Drop it in for t, put it in your calculator, and get your answer. All right, for D is asking, estimate when there'll be 1 million farms. All right, so for D, you're actually making P equal to, now in this notation, P is going to equal 1. All right, and then solve for T. Now I don't have enough room to actually do this one here, but we're going to do another one, I think on the next page. Hang on. Let me just check before I say that. Yes. All right, so we're gonna do some on the next set that are asking to solve for t like that. Okay, but you end up having to use logs to do it. All right, now there was another one on this page which was number 17. All right, number 17. Ah, good. All right. I don't actually need to write anything down. I can just explain this one. All right. And it comes down to understanding what half-life is. So one of the major problems associated with any organ transplant is a long-term risk of rejection despite the patient taking anti-rejection drugs for the rest of their lives. The percentage of individuals who have not rejected a transplant organ can be modeled by an exponential decay function as the function of time as a function of time in years. According to one study, the half-life of kidney transplants done in 1988 was 9.1 years. According to another study, the half-life of kidney transplants done in 1996 was projected to be 13.3 years. Is this later result good or bad news? All right, well, think about this. In 1998, all right, after 9.1 years, half the patients had rejected their new kidneys. That's bad. Rejecting the kidney is bad, not necessarily the time frame. In 1996, all right, after 13.3 years, half the patients had rejected their new kidney. So in 1996, it was taking longer before patients rejected their new kidney than it was in 1998. In 1998, half had rejected in 9.1 years. In 1996, half had rejected in 13.3 years. All right, so that is a good result, all right, that they were going longer without rejecting their kidneys. All right? That's all that one is. There's no math involved there, just interpretation. All right, where are we? We're almost done. Yes, I believe this is indeed the last page. Okay, so the last 3 questions come from page 112. So for me, that's, I think, 132. And the first one is number 5. Okay. All right, now all of these involve either half-life or doubling time or percentage remaining time. So these all fall into the same category here. So Let's see. Because of ardent fishermen during the summer months, the population of fish in a lake is reduced by 10% each week. Find the half-life of this dwindling population of fish using logarithms. There's a hint there, okay? We're going to have to use logarithms to solve this. All right, so first of all, we need to set up our equation. So the information we have there says that the fish are reduced by 10% each week. Okay, so that means, hang on, I need a blank piece of paper here. All right, so what that means is my R, my rate of decay, or my growth rate, whatever, is negative 10%. So I'm going to say negative 0.10. So that makes C 1 plus negative 0.10, which is going to be 0.9. So I can write my exponential growth decay equation here, right? P0. C is 0.9 to the T. Now, to find the half-life, I don't need any other information than that. Because remember what half-life means. It means after however many years, half your original amount remains. So my original amount is P0. So after how many years do I have half of P0 left? All right. I can divide both sides by P0, and if I do that, I have 1/2 equals 0.9 to the T. Now, because we're working primarily in decimals, and we're going to stay working primarily in decimals, I am going to leave that as 0.5. 0.9 to the T. All right, so now I have to solve this, and what I want to solve for is sitting up there in the exponent, which means I need logarithms. Take the log on both sides. All right, use your log property that says that that exponent can now land out front there. So I've got log 0.5 equals T times log 0.9. Divide both sides by log 0.9. We get log 0.5 divided by log 0.9, and that's T. So now T is, what is T? What did I get for T? Hang on. 6.5788. 6.5788. All right, so approximately 6.5 years. I'm sorry, weeks. All right. So again, what that means is after 6.5 weeks, half the original amount of fish will be in the lake. All right. And that's the answer for that one. All right, now number 7 was the next one. Number 7 has multiple parts. I will do one of them. All the other parts are the same as the one that I do. Don't worry about part B. Just worry about part A, finding the doubling time. All right, so it says find the doubling time for each of those interest rates or growth rates, whatever they are. I'm going to do 3%. You can follow what I do for 3%, for 4%, and 5%, and 6%, and 7% if you choose. Okay. So again, we're starting off with a growth rate of 3%. So that's 0.03, which means my C is going to be 1 plus 0.03 or 1.03. So my original function is now P of T equals P0 1.03 to the t. Now the difference here is that we're doing doubling time, not half-life. So that means after how many years we'll have twice p0 left. So that's 2p0 equals equals p0 times 1.03 to the t. Divide out p0. All right. And now we solve this one the same way we did the other one. We've got to get the t out of the exponent. So log both sides. And while I'm doing this, I'm going to apologize for the background rumble. My furnace just came on. All right. So I'll bring the t in front. Divide both sides by log 1.03 for t. Drop that into your calculator. And what do we get for that? We get t equals 23.4498. 23.4498. All right, so these were annual growth rates. So the doubling time is approximately, again, approximately 23.5 years. Okay. All right, so doubling time and half-life, the process itself is identical. It's just whether you're doubling it or cutting it in half. All right, now what about if it's not doubling or half? All right, if we jump over to number 14 here, which is over on the other side of the page. All right, let's see. So for this one, I think I got, yeah, okay. All right, so a radioactive substance decays exponentially so that after 10 years, 40% of the initial amount remains. All right, find an expression. I'm going to do A, and then again, BC is just, all of that is just plugging in. Okay. Okay. So find the expression for the quantity remaining. So once again, clean page. And so after 10 years, so when t is 10, 40% remains. So that is, hang on a second, 0.4 remains. All right, so that's what we've got now. What we need to find to make the equation is going to be C. So what I have here, when I write my equation out, P of t is P0 C to the t. All right, so I have t, and I have a percentage of my original amount left. So over here is going to be 0.4 times P0, P0 C to the, that happens 10 years later. Okay. All right, so this represents the 40% of the original that's remaining. Again, from here on out, divide out P0 from both sides. So 0.4 equals C to the 10. Now this time I'm looking for C, so that makes the algebra a little bit easier. It's going to be 0.4 to the 1 over 10. And when you put that into your calculator, you'll get 0.9124. 0.9124. All right. So when I put my equation back together now, I've got P of t equals P0 times 0.9124 to the t. All right, now to answer the rest of the questions, what percent of the original, no, wrong question. How much will be present after 25 years? Just plug in. We're going to look at, oh, just assume P0 is like 1 or something like that, because you'll be looking at a percentage. All right, that's the only way you can answer this question is as a percentage. But don't worry about that. I'm actually not gonna ask you specifically something like this. I mean, I might ask you to find the equation, but I'm not gonna ask you unless I give you an actual amount to start with here. All right, so don't worry about the rest of number 14 there. That's not a big deal. Make sure you know how to find the equations. That's the important thing with all of this. All right. Okay, so let me get this video compiled and up and out to you.